Hello everyone, let's solve another Leetcode problem today. In this problem, we are given the definition of a monotone increasing binary string. This type of string contains a streak of zeros and it can be followed by a streak of ones. For example, this is a valid string because it starts with a streak of zeros and the streak of ones follow it. Similarly, if we just have a streak of zeros, this will also be a valid string. And if we have just a streak of ones, it is also a valid string. On the other hand, if we look at this string, there's a 0 that comes after 1, so this is an invalid string. We are given a binary string in this problem, and we are allowed to flip any digit, and we have to return the minimum number of flips required to make the string valid. Let's look at this example. When we look at the last 0 in our string, we see that it comes after 1, so this is a violation. To fix this, we can flip this to 1 and our string is now valid. So we were able to fix it using only one flip. Now let's take a look at this example. We see that this is invalid because zeros are following 1. So if we flip these two zeros to 1, our string will now be valid. So we could make this string valid by only using two flips. Let's try to come up with an intuitive solution for this. Let's have a look at some valid patterns for a monotone increasing binary string. Firstly, we could have a string like this where a streak of zeros is followed by a streak of ones. We could also have a pattern just containing a streak of zeros. And similarly, we could have a pattern just containing a streak of ones. In the first pattern, you could see that we are allowed to transform from a streak of zeros to a streak of ones. But on the other hand, we are not allowed to transform from a streak of ones to a streak of zeros. Now let's look at some scenarios where we have a streak of zeros and depending on the next digit how it would play out. Let's take the scenario when our next character is 0. In this case, we can just add this and there will be no violation, so we could continue with our streak of zeros. Now let's take the scenario when our next character is 1. In this case, we have two choices. We can flip this character to a 0 so that there is no violation and we can continue with a streak of zeros. On the other hand, rather than flipping this character, we'll keep it, and since we have started with a 1, our streak of zeros has ended and a streak of ones will start. So in this case, we have two ways to go forward, and whichever one results in the minimum number of flips should be adopted. In the first option, we are already using a flip, so we also have to count it. Now let's look at the case when we have a streak of ones. For our next character, there can be two scenarios. If our next character is 0, then we have no choice but to flip it to 1 and we can continue with our streak of ones. And if our next character is 1, we can directly include it and continue with our streak of ones. So you can see that for a streak of zeros, when we encounter 1, we can go down two paths and we have to choose the one which results in the minimum number of flips. And in our journey, we have to make multiple such decisions and many of them will lead to the same sub-problems. So to avoid recomputation, we can use a dynamic programming approach. The time complexity of this would be O of n because we only have to visit all the characters once for each of these two streaks. And the space complexity would also be O of n because we have to store the results for each character for each of these two streaks. Let's implement our solution. Let's define our recursive function which takes in two parameters, the index of our current character and our current streak. We'll now write our base condition that if we have reached the end of the string, in that case, no more flips will be required. Now let's write our happy scenario in which our current character is the same as our current streak. In that case, we'll not require any flips and we can continue to check for the next character and we'll continue with our current streak. Now let's handle the second case in which our current streak is 0 and our current character is 1. In this case, we have two options. In the first option, we could flip our current character to 0 and then continue with our streak of zeros. But in this case, we'll be using a flip, so we'll increment the result by 1. And now for our second scenario, we can keep our current character and now start a streak of ones. Whichever of these will result in the minimum number of flips is our answer. Now let's consider our last scenario when our current character is 0 and our streak is 1. In this case, there is no choice but to flip our current character to 1 and then continue with a streak of ones. We are now done with our recursive function. Let's make sure to cache the results. We can now call this function for the 0th index with the current streak as 0. We are now done with our DP solution. Let's look at another approach to solve this. Let's have a look at this example. Since our string can start with a streak of zeros, any streak of zeros at the start will be valid. And now when we look at these two ones, since we can have a streak of ones after a streak of zeros, this will be valid. But when we look at our next character, we see that there's a violation. To fix this, we could either flip the two ones before it and continue with our streak of zeros, or we could let the previous ones remain as they are and flip our current 0 to 1. In our first choice, there will be 2 flips required, and in our second choice, only 1. So the second one will be more optimal. Now when we go to our next character, assuming that we have already fixed our previous string, even if the previous string is a streak of zeros or ones, our current character 1 will still be valid. This is because even if we have fixed our previous string to be a streak of zeros, this can mark the beginning of a streak of ones. Now when we go to our next character, we see that there is a violation. To fix it, we either have to flip all the previous ones to zeros, or we could flip these two zeros to 1. In the second case, we'll be using less flips, so this will be more optimal. Now let's try to come up with a generalized solution for this. When we are trying to fix this character, we have two choices. Either we could flip the 3 previous ones to 0, or we could flip the zeros which occur after this point, because prior to that a streak of zeros is valid. So we have these 3 zeros that we can flip, and in both these scenarios 3 flips would be required, so we could choose any of them. Hence, to be able to use our approach, we need to keep track of the previous ones and the number of zeros that occur after the end of our first streak of zeros. So when we encounter these two ones, we'll keep a track of it. We'll also count the number of zeros. Now when we go to our next character, we see that there's a violation. We'll also increment the count of zeros encountered. Now to fix our violation, we could either flip the previous ones, or we could flip the current and the previous zeros. The second option would be more optimal. For our next character 1, it does not matter whatever streak was before it, so we'll just increment its count. For our next character, we'll increment its count. We'll flip the 2 zeros to 1, and this will be more optimal. Similarly, for our next 0 character, we'll increment its count. In both the cases, the number of flips required would be 3, so we could choose any of them. For our next character 1, there will be no violation, so we'll just increment its count. And for our last character 0, we'll increment its count. In both these scenarios, 4 flips would be required. The time complexity of this would be O of n because we only have to go through the characters once. And the space complexity would be constant because we just have to maintain the count of ones and zeros. Let's implement our solution. Let's keep a variable to store the count of previous ones and initialize it to 0. Let's also initialize our result to be 0. We'll go through all the characters in our string. And if our current character is 1, then we'll increment the count of ones. We can use this Python technique to check and increment at the same time. Since we only have to handle the case when our current character is 0, in this case there is a violation, and to fix it we'll have to either flip the previous ones or the count of zeros after the end of our first streak of zeros. You can notice that this result variable in this case would store the count of previous zeros, because every time we are minimizing this with the count of ones and the count of zeros. So if our result plus our current 0 is less than the count of ones, in that case our result must store the count of zeros. If this part is unclear, you could easily store the count of zeros. And once we are done going through all the characters, we can return our result. Let's submit our solution. You can see that our solution is accepted. If you have any doubts or concerns regarding this solution, please mention in the comments. If you thought this video was helpful, please leave a like and subscribe to the channel for more such content. Thanks for watching.